After the Big Bang. The Big Bang is the origin of the universe, occurring approximately 13.8 billion years ago. The first period of time immediately after the Big Bang is known as the Planck epoch. Little is known about this period, but it is thought that all the four fundamental forces were unified at this point, serving as one superforce. After the Planck epoch was the ground unification epoch. The universe was smaller than a quark, with temperatures higher than 1024 Kelvin. By the end of the grand unification epoch, the universe was about the size of a proton. The grand unification epoch was followed by the inflationary epoch, during which the universe expanded many times faster than the speed of light. Nothing that was space itself was expanding, even though nothing within space broke the universal speed limit. After the inflationary epoch, the universe continued to expand until it became what it is today, a behemoth at least 92 billion light years in size and maybe much more.
Galaxy formation period. Scientists are led to believe by observations by the Hubble Space Telescope that the first galaxies took shape as little as 1 billion years after the Big Bang. As to how these galaxies were formed, they remain divided. There are two leading theories. One says that galaxies were born when vast clouds of gas and dust collapsed under their own gravitational pull, allowing stars to form. The other one states that the young universe contained many small clumps of matter which clumped together to form galaxies. The Hubble Space Telescope has photographed such clumps, which might be the precursors to modern galaxies. As our universe has evolved and expanded, small galaxies are often merged with the larger ones. In fact, a large portion of the bright galaxies that we see today may have formed from the mergers of two or more smaller galaxies. Galaxies are not the only massive bodies to merge in the outer space, though. Black holes also merge to create a bigger, massive black hole. We can detect this phenomena because of the gravitational waves that come from the dance between the two black holes as they rotate against each other to merge. After the merger between smaller galaxies, the resulting massive galaxy is either left to evolve in isolation, which would likely result in a large spiral galaxy, or it would evolve with other mergers and interactions, which would result in a large elliptical galaxy.
The Sun, the heart of the solar system and the biggest object within it. Born about 4.6 billion years ago, our lovely Sun holds up to 99.8% of the solar system's mass and 109 times the diameter of Earth. Now, as you may know, the Sun is also one of the billions of stars in the Milky Way galaxy. But another fact to take into consideration is that our Sun is part of a generation of stars known as Population 1, due to its relative young age and abundance in elements heavier than helium. Astronomers believe that the galaxy has four major spiral arms: Perseus, Cygnus, Scutum-Crux, and Sagittarius. However, the Sun is located in the inner rim of the Orion arm, which is thought to be an offshoot of the Sagittarius arm, meaning that the Sun is about 26,000 light years away from the center of the galaxy. Many scientists believe that the Sun and the rest of the solar system formed from a giant rotating cloud of gas and dust, known as the solar nebula. As the nebula collapsed, because of its gravity, it spun faster and faster until it flattened into a disk, which caused that most of its materials were pulled towards the center of the solar system to form the Sun, as seen in the image.
Billions of years ago, Earth, along with the rest of our solar system, was entirely unrecognizable, existing only as an enormous cloud of dust and gas. Eventually, a mysterious occurrence, one that even the world's foremost scientists have yet been unable to determine, created a disturbance in that dust cloud, setting forth a string of events that will lead to the formation of life as we know it. One common belief among scientists is that a distant star collapsed, creating a supernova explosion, which disrupted the dust cloud and caused it to pull together. This formed a spinning disk of gas and dust, known as a solar nebula. The faster the cloud spun, the more the dust and gas became concentrated at the center, further fueling the speed of the nebula. Over time, The gravity at the center of the cloud became so intense that hydrogen atoms began to move more rapidly and violently. The hydrogen protons began fusing, forming helium and releasing massive amounts of energy. This led to the formation of the star that is the center point of our solar system, the Sun, roughly 4.6 billion years ago. The formation of the Sun consumed more than 99% of the matter in the nebula. The remaining material began to coalesce into various masses. The cloud was still spinning, and clumps of matter continued to collide with others. Eventually, some of those clusters of matter grew large enough to maintain their own gravitational pull, which shaped them into the planets and dwarf planets that make up our solar system today. At its beginning, Earth was unrecognizable from its modern form. At first, it was extremely hot, to the point that the planet likely consisted almost entirely of molten magma. Over the course of a few 100 million years, the planet began to cool and oceans of liquid water formed. Heavy elements began sinking past the oceans and magma toward the center of the planet. As this occurred, Earth became differentiated into layers, with the outermost layer being a solid covering of relatively lighter material, while the denser, molten material sunk to the center. There are a number of theories about how the moon was made. The capture theory suggests that the moon was a wandering body, like an asteroid, that formed elsewhere in the solar system and was captured by Earth's gravity as it passed nearby. In contrast, accretion theory suggests that the moon was created along with the Earth at its formation. Finally, according to the fission scenario, Earth had been spinning so fast that some material broke away and began to orbit the planet. But the most widely accepted theory today is the giant impact theory. It proposes that the moon formed during a collision between the Earth and another small planet about the size of Mars. The debris from this impact collected in an orbit around Earth to form the moon.